Okay, so talked about using table F earlier and talked about margin of error examples earlier. And so here we're going to talk about how to actually calculate what a margin of error is going to be. Since this was last semester's notes, again, obviously trying to get people to look up, but also just an extra explanation of that margin of error. So similar to the examples we saw, if you have a polling data that says 52% favor John Smith and 48% favor Jane Doe, plus or minus 3 points. So, they say points, they mean percentage points. You see that a lot. The plus or minus 3 points is that margin of error. So like we said before, we would add 3 and subtract 3 from, whatever they tell us in order to know the actual range. So polling is not exact science. It is, kind of squishy-wishy, wibbly-wobbly, and has a lot of gray area. So if they did a poll and they said 52% of people favor John Smith, plus or minus 3, that means with that margin of error that his favorability rating is actually between 49 and 55%. So 52 minus 3 gets us 49. 52 plus 3 gets us 55. And likewise, do the same with the other candidate, Jane Doe. She was at 48%, so we subtract 3 to get 45, add 3 to get 51. So her range is from 45 to 51. So very close, right? So they are within that margin of error, and it would be a very close race. Okay. So how to get the margin of error? And you'll see that to abbreviated, you might see it margin, MOE, so margin of error. And then just math-wise, when you see the big E, this is what it means. So big E means error, margin of error. So we see here we have a number. Doesn't look like a number, right? But it's a value we're going to put in. And we're going to multiply this by our standard deviation divided by our square root of n. So hopefully, if you did the previous homework on the central limit theorem, this should look familiar, okay? That is that bottom value for our z-score in that. This symbol, again, is the population standard deviation. It's going to make a difference later. N is the number of, people or objects. It's your sample size. And this value, this Z alpha number, that's what we get from table F, okay? And I know it says Z and it has a funky looking A to it, so that's a Greek letter alpha. And you see this over 2, okay? This whole thing is a symbol. And it does look like it's saying divide whatever this is by 2, but don't. It's there for a reason. There is a time to do that. This is not the time. So big, caveat, do not divide by 2. Do not, okay? Sometimes, no matter how many times I write that on a board or say it out loud or write it down in notes or say it out loud or say it out loud, there's always a few of you that will get this number from the table and divide it by 2. Do not do that. I'll tell you if you have to. Right now, you don't have to. Okay. So we're going to use this information from this example and put this in and then do the math. Okay. So formula to find the margin of error tells us that, gives us the example. So it says the number of square feet per house is normally distributed with a population standard deviation of 137 square feet. So that makes a big difference about population standard deviation. A random sample of 19 houses. So that's the number of houses in our sample. Random sample of 19 houses is taken and results in a sample mean of 1,350 square feet. Find the margin of error for an 80% confidence interval. Okay, so it gives us the average, but we don't have a place to put the average in there, okay? This is one of those situations where you might get more information than you actually need. What you need is the standard deviation, sample size, and then a confidence level in order to know what to look up and what number to put in here, okay? So it says 80%, but we don't put 80 and we don't put 0.80 at all. This is how you do it. So you're gonna whip out that table F, or click on it, I guess. All right, and you see right here, it says, see this will focus in. There we go. Confidence intervals on the top. And we see 80% right here. So 80% is the lowest confidence level that we're gonna get. And then we go all the way down and we see that Z number right here. Hopefully you can see it. So right here it says Z, and this is the number right here. So 1.282 is the value we're gonna put in right here. Okay. So now we have our numbers, and it says we're gonna put in this. All right. So again, you can try to do this in your calculator at once, but I just recommend getting this first and just work backwards, right? Get this first and then multiply it by that. Because you're going to have to use a lot of parentheses if otherwise, which is fine. But if we do this, we get that answer. So we do 137 divided by the square root of 19. Okay. Hit enter. So we're going to take this number and times it by this. So in your calculator, if you just hit, after you get that value, hit times, then we can put in 1.282. And then this is where you want to be careful about rounding. So if you are rounding as you go, then right here, you want to make sure you go out, you know, definitely 4 or 5 spaces, okay? I just would, you know, keep it safe. Don't even round it, just hit, you know, times, and then that'll put in that last answer. And here it says 40.29, blah, blah, blah. And the answer says round your answer to 2 decimal places. So our margin of error is going to be 40.29. That would be typically that plus or minus. All right. So what does that mean? That means that we're 80% confident, so not really a whole lot confident, but we're 80% confident that the square footage of these houses will have an average of 1,350 feet plus or minus 40.29 feet. So some houses are going to have a little bit more, some houses are going to have a little bit less. Okay, so margin of error tells us what we would add and subtract to the average to get that interval. Okay. Hopefully that works for you. All right, so we're going to do another example in the next video about how to find the sample size in this type of scenario. Okay. So hang in there with me. We're almost there.